To begin sample preparation for the direct simple shear test, you'll need your bottom platen and a membrane cut to the size or the height of your sample. Here I'm inspecting the membrane for any tears, and I found one. And now I'll see if the other side has any tears. And it doesn't, so that means I can use the bottom side of this membrane, cut it in half, and then place mineral oil around the bottom platen so that the membrane easily slides over the top. So I slide the part that I did not cut, the flattest part, down into the groove. Now you're ready to add your first set of rings. Here, they should line up with the holes on the bottom. You can kind of see they should be flush. Anywhere there's a groove, therein lies a greased O-ring. So this has been vacuum greased with, vacuum grease. And then you'll see all of these holes right here. And so it's good to make sure that all of those holes, just try and eye it, that they all line up. Okay, so we have our membrane in there, and then our first set of rings. I'll kind of just hold this in place by sticking one of these screws in to make sure that it'll stay where it belongs. So I'll just do one on each side. Just like that. So that way it doesn't move while you're kind of installing these rings and the other things as well. So again, you'll see I've measured these out. This is exactly 1 inch in thickness. And the DSS is a little easier because you can kind of just slide this on top like that. And then your rings are oriented in such a way that they line up with these holes. So everything kind of like matters where the holes are on the whole build itself. So we'll kind of keep those there. And if you want to make it easier on yourself, you can add have something holding it there for now, like this. And this will come in handy later. So now that I've done that, these rods will come in handy. Carefully guide it down into its spot. And so you don't want too many gaps in between these two, so I'll just press down as I go. Then I'll tighten the sides first. Now the little ones. Here we go.
It's not running from you. It's not. Stop.
And this will compress these more as well.
Oil.
Yeah. So as I do that, it'll come down. That looks good. And I don't tighten them all down kind of the same way that you would change a car tire. I just try and bring them down enough, and then I'll go back and tighten them again, so you can do it in like a sort of a star-shaped pattern. Come back over here and tighten, and then here. That's good. And then the last one over here. All right, and we're looking good. So then the next step is this bad boy. You can tell that this is the piece that goes on top of this O-ring. It'll have a little groove on the inside. And then again, you kind of pick out where it goes based on these notches. And they will rest around. Like so. This part is a little more difficult, but this will not stay on during the test. Some of these pieces, the whole point of the test is to sort of shear it sideways. That's why we have those rings on it. And so some of these pieces will be removed whenever we actually start the test to allow movement, because right now the soil that we build inside here won't actually be able to move at all. So same thing, I'm going to tighten them down just slightly. Make sure that my screws are in the holes. I'll push down, push together, and continue tightening. Until they're just flush. So for the direct shear in the photos, you can see that there's another set of rings because that direct shear has, the bottom kind of looks like this. So you need to add more rings in order to just make up for this part. But other than that, everything is pretty much the same, but you can kind of see in the photos how to do the direct shear sample prep. And then this whole video is just for, shear wave velocity. And this video is just for the direct simple shear test, but they're both pretty much the same. And dismantling is the same as well. So the video for dismantling is using the shear wave velocity mold. So you'll get to see the differences there. And then I tighten in sequence. There's two little gaskets right here that I had already greased before this started. You can see the black here. These O-rings, sort of gasket parts, and there's vacuum grease on them, so that's kind of an important part too. Okay, so now we have our sample built. I'm going to remove these rods that I placed in there because it shouldn't move now. Now we can start putting our soil in there. So all of that work just to put in a little bit of sand or clay or whatever you have. So the sample prep for sand will be different than clay. We do dry fluviation for sand. And so I've done some calcs before this video, and then that'll be in the next video so I can get this thing out so you can pause. Okay. So I'm just gonna attach this. This is for the vacuum. It'll suction the membrane close to the rings, that way we can actually get, you know, the way that our specimen, or the actual relative density that we want based on the volume that we've calculated here. So there's a male and a female end. And so I do the male first because it's easier to screw in that way. And just bring it up to a hand tighten on the female end. And once that's done, you'll tighten it down with your wrench. You get just enough resistance that you know you can take it off after with a wrench. Okay. So this is kind of the moment of truth to see if you've gotten a good seal. So we're going to stretch this membrane around and down. sometimes I'll put vacuum grease in the creases between the rings. Just in case they're not flush quite enough. This isn't necessary, but I've had good luck with it. Okay, then we will connect our vacuum wherever it is.
It's probably connected to that glove.
Whoops. Okay, so ideally, if this were a true test that we were running without, just for this this video, everything would be flush, so it would come in sort of like this. But honestly, this is, for the DSS, this is actually a pretty good sample, so you can see that the membrane is sort of pressed way up against these rings right here. It's totally flush. So from here down, we actually can build a pretty nice sample with this. So this is the most important part, and this shows me that there's no leaks in the membrane as well, which is really important because we're probably going to saturate this sample. And even if it weren't saturated, we wouldn't want anything to sort of just leak out of this membrane and go into everything else. So now we're ready to dry pluviate our specimen. And so I have just a funnel here, and then I've weighed out my sand. And this is kind of easier to do with 2 people, but
We'll hold it.
for now we'll just do it like this, but it's dry pluviation the same way that you would do anything else. It'll go around. The middle. Like I said, whenever you're preparing a looser sample, your funnel will be a little bit closer. So you're sort of just placing it. You can pause it. So there's a couple of things to look out for. And it's that there's this groove right here, and there's also a groove shown here. And that's how you know the orientation that you want to place it. So you'll kind of look, and you don't want to twist it while it's placed on there. So, is it about level right there?
Yeah.
Okay. So once you do this, you're placing it on here, so it's applying a load right now, but a very small load. And there's not really much you can do to get around that. But we will put our rods on now. You can probably stop videoing this. Now you're ready to put it in. And so there's 2 sort of, want to carefully slide it in. To the top. Just like that. And then we'll lower this So this piece detaches. And we'll slide it in just like so. Carefully. Kind of flush, and so you want these holes to kind of line up. Then I'm going to lower this by using knob 2. And if you look over here, it's at 60 psi. So I'll turn it down and hear it going. Once it gets below about 40 psi, it'll start to lower. You can see it lowering. And I'll slowly lower it and then make sure that these tubes stay out of the way. Pause it there. Now, and to do that, we kind of just open up this little valve here. We're basically going to run water through the DPT. I'm just going to open it up. And then over here, if you look, here it says DPT here, and we want to turn it to on. The water is on. The DPT, and you can see that water starts coming out. There it is. You want all of the air bubbles to evacuate, and you can cut it. So now that the DPT is saturated, I'll close it while there's still water flowing through it. And it's saturated, and I'll turn DPT off or off. And there it is. And I had to add this fitting to the tube that's actually attached to the bottom platen. And so this fitting follows this part right up here and into there. And I might actually change the fitting so the flow in will go here and the flow out will go here. So before you start any testing, you'll take this piece off and it'll... So now you're ready to do your saturation through B-value check. And for B-value check, or back pressure saturation, I should say, this pump is what's going to be applying that pore pressure into your sample. This is what's going to be actually saturating your sample. So we have our knob turned to the direction that it's going to go. So water will flow through this pump. You can see the pump is pretty full. It'll flow through this pump and into your specimen. And then to change the pore pressure that's applied, right now I just have the software open that controls the pump. And so we're going to focus on these things right here. So right now this pressure is reading negative. That's because it needs to be calibrated. So we calibrated before the test, and now we'll probably have to calibrate after. But you should calibrate it as it was shown earlier that we discussed before you run every single test, because the pressure that's being read from the DPT should match. And so we sort of went over that as well. But for saturation, and the pressure that you want to apply to the specimen comes here. So if you want to increase pore pressure, maybe not by 30 kPa, but if you want to increase it by maybe like 5 kPa, and then increase your confining pressure to something else, whatever your calculations are, this is how it's done. So you'll click, or you'll enter in the pressure that you want to add, then you'll do start, and negative pressure here, that means it's sucking water out. So this is how we sort of filled the pump. Pushing water into the sample will read a positive pressure. So you don't want to do a negative pressure whenever you're trying to do back pressure saturation. So that's how you apply your pore pressure, but we also need to apply a confining stress. So this software is also used for your DSS test, but this is how you're going to apply your confining stress. And so I don't have it running right now, so that way I can sort of show you where it's lying, but this is a completed DSS test that we ran for this video actually. And in your spreadsheet, you'll see that there's a place to sort of put this amplitude in your spreadsheet, and it will return to you a pressure in kPa. Now, the effective confining pressure that you apply during back pressure saturation should not be greater than the confining pressure that you're running your test at. So say your confining pressure is, I don't know, 60 kPa. This should never ever go over 60 kPa. The effective confining stress should never be greater than that, because that will lead to overconsolidation and you'll have to start the test all over. So in your spreadsheet, you'll see that there's a place to put this amplitude, and it will always sort of look like this. It's never going to be a really nice line. So you're going to take the average. So I would say the average is right about here, and maybe I would take negative 0.000346, and I would plug that into the spreadsheet that's been provided to you. And then I would adjust it. So you're going to check to see what it's reading right now. Maybe it'll say like, I don't know, 20 kPa or something, but you want to increase it for your back pressure saturation. The way that you increase it is, one, you'll plug in the effective confining stress that you want. That way you can back calculate what amplitude it needs to read. So say if you want 40 kPa, plug that into your spreadsheet and it'll give you an amplitude. So you need to change this amplitude, what this reading is. The way you do that is you turn this knob. And this knob can be difficult to turn at the beginning. So the best way to do this is to place your hand on it, sort of press down, and press down harder than you turn, so that way you don't get the sort of jerking motion. And whenever you're first doing this, it might take many, many, many turns to get to where you're wanting to go, but it is much better to go slowly whenever you're turning this to increase the pressure, because you can easily overconsolidate your specimen by turning it too much, and then again you'll have to start all over. So we don't want to do that, so be very careful with this part. So now you're ready to start your DSS test. The most difficult part of this test is the sample preparation and the back pressure saturation and your B-value check. So the DSS test itself is very simple. We've already got everything set up in the DSS test. And there's only a few things that you need to do. And the first thing, and I'm not going to turn it on because it's too loud for this video, but you'll turn on this pump, and it's really easy. You just press start. So press start, and then you'll have your data set up. Here you've already chosen your output file path and your output file name. So in this case I have Maya as the name, and then you'll just hit run and it will run your DSS test. And so these are all things that you will determine based on your calculations. So your amplitude goes here, the number of cycles, your sample rate is the rate at which it will read the recordings, the frequency. So all of this is stuff that you need to put in here for your test. And then you'll click run, and then once it's done, you'll have your data here, and then you can export it. It should go into this file path here, and so you'll be able to open it up and it'll give you an Excel sheet. It looks like this. And now you can do your analysis from the results that you were given. And that's how you perform your DSS test. After this portion, then you'll need to dismantle your specimen or take it out of the load frame. And so I'll briefly go over that as well.